Section 14.2, Chapter 6.5, Graphs of Other Trigonometric Functions. Our objective is students will successfully sketch the graph of tangent functions. We're going to say let y equal tangent theta. And we want to fill in the following table just like we did for sine, cosine, and tangent. Or for sine, cosine, sorry. We're doing tangent now. So, you can use your calculators. Make sure that your calculator is in radians. And you want to go do tangent of negative pi over 2. And you should get an error, so we are going to call that undefined. Okay, now do tangent of negative pi over 3. Round to 1 decimal place, so we get negative 1.7. Do tangent of negative pi over 4. Rounding to 1 decimal place, we get negative 1. Tangent of negative pi over 6, we are going to get negative 0.6 rounding to 1 decimal place. Tangent of 0 is 0. Tangent of pi over 6 is 0.6. Tangent of pi over 4 is 1. Tangent of pi over 3 is 1.7. And tangent of pi over 2 is undefined. Okay. Now we're going to go ahead and plot those like we did with sine and cosine. As you notice, at negative pi over 2 and at pi over 2, I've already put in dotted lines. This is because they're both undefined. These are going to be asymptotes for our tangent graph. Okay, now plotting at negative pi over 3, we are at negative 1.7. And we're just going to go ahead and approximate those. At negative pi over 4, we're at negative 1. At negative pi over 6, we're at negative 0.6. At 0, we're 0. At pi over 6, we're at 0.6. At pi over 4, we're at 1. At pi over 3, we are at 1.7. And now, go ahead and connect those. And it looks like that curve. Okay. It looks similar to our x cubed curve. However, it actually isn't exactly the same because remember our x-axis is in radians and not in single units. Okay. Our important points for these graphs are negative pi over 4, negative 1, 0, 0, pi over 4, 1, along with the two asymptotes. You have to have the asymptotes on the graph when you graph. So if we want to continue graphing past pi over 2, what do we think is going to happen? Well, we know that we can continue around the circle for degree measurements greater than 90 degrees. So that should already give you a clue that tangent of theta is going to go on past pi over 2. Okay? As you can see, it's just going to repeat. Okay, what would happen if you continued to 6 pi? It would still repeat. Okay, this is because y equals tangent theta is periodic. And as we learned last section, periodic means that it's going to repeat after a certain amount of time. Okay. We want to know what is the period of the tangent function. Well, you have to take into account that you're going from negative pi over 2 to pi over 2. Okay? Not 0 to pi over 2, but negative pi over 2 to pi over 2. And you want to ask yourself, how far is that? Well, 0 to pi over 2 is pi over 2, but then 0 to negative pi over 2 is a pi over 2 also. So pi over 2 plus pi over 2 is pi. So the period of the tangent function is pi. Just like with sine cosine graphs, you can move the graph of tangent and stretch the graph of tangent. Okay. When you look at the generic of y equals a tangent b theta minus c, you can tell how the graph changes by using the a, b, and c. Okay. A stretches or shrinks the graph vertically because it is on the outside of the tangent function. B stretches or shrinks the graph horizontally. Remember, it works inversely, so if it's a 3, that really means that it's going to be shrinking the graph by a third. If it was a 1/4, then it would be stretching the graph by a factor of 4 horizontally. Okay, and C moves the graph left and right. Remember, in order to move left and right, if there is a B, you have to take C and divide it by B, and that will tell you what you're moving left or right. How to find the asymptotes? Okay, this is if you can't think of it in your head, and these graphs do get pretty complicated, so it's nice to have this formula. So for the leftmost asymptote, you're going to take the inside, so b theta minus c equals pi over 2, equals negative pi over 2, sorry. And you're going to go ahead and solve for theta. Okay. For the right asymptote, you're going to take b theta minus c, so again the inside, equals positive pi over 2, and you're going to solve for theta. And these will give you your right and left asymptotes for the period of tangent. Okay. The x-intercept is the midpoint of the values between those two functions we just discussed. Alright, so looking at y equals 3 tangent of theta over 2. First thing you've got to ask yourself is what's going on with this graph. We need to find our asymptotes first. So we're going to take our inside, b theta minus c equals negative pi over 2, and b theta minus c equals pi over 2. Okay. Our b theta minus c, there is no c involved in this equation that we have. We just have theta over 2. Okay. So our c is really 0. So if we solve for theta, in both these cases, okay, 0 drops away and we're going to have to get rid of the 1/2. Get rid of the 1/2 by multiplying by 2. So we get our left asymptote at negative pi. Okay, solving our other one, multiply by 2, and we get theta equals pi. So our two asymptotes are at negative pi and pi. Okay. To put out our other marks on our x-axis, we're going to go from the y-axis over to pi. And that mark in between is halfway in between. So we're going to cut that in half. Between 0 and pi, cut pi in half. Okay. So we've got negative pi over 2 and pi over 2 is going to be those halves. The x-intercept is at 0 because we have no moving up or down or moving left and right. Okay. Now, we know our next important point is at pi over 2 and it's normally 1. But remember, we have a vertical stretch by 3. So these 3's stretched the y-axis by a factor of 3. So that first mark is no longer a 1, it's a 3. So our important points are negative pi over 2, negative 3, 0, 0, pi over 2, 3. Okay, the graph of cotangent. We want to think of cotangent equaling 1 over tangent so that we can get our parent graph for cotangent. We already know the tangent graph looks like this, and we're going to use that. Okay. We're going to do the table of theta, tangent theta, and cotangent. So when theta is 0, tangent is 0. Cotangent is going to be 1 over 0 because cotangent is 1 over tangent. Well, 1 over 0 is undefined. So cotangent is undefined at 0. So we have an asymptote on the y-axis for cotangent. Okay, now we're going to do pi over 4. Tangent of pi over 4 is 1. Cotangent of pi over 4 is going to be 1 over tangent of pi over 4, so 1 over 1. 1 over 1 is 1. So cotangent of pi over 4 is 1. Okay, next up is pi over 2. Tangent of pi over 2 is undefined, which we got that by having 1 over 0. But cotangent is the reciprocal of tangent, so that is going to be 1 over 0, which is going to be 0 when you keep change flip. 3 pi over 4 is our next value. Tangent of 3 pi over 4 is negative 1. So cotangent is going to be 1 over negative 1, which is negative 1. And last up is pi. Tangent of pi is 0. Cotangent will be 1 over 0, so that is undefined. So we have an asymptote at pi for cotangent. Okay, and if we go ahead and sketch our graph, there is cotangent. Notice tangent and cotangent are 90 degrees shifted from each other, and there is a vertical flip when you compare those graphs. Our asymptotes for cotangent, if you like the equations, rather than thinking did it move it left or right, you can take your inside, b theta minus c, and set it equal to 0, because that is our left asymptote. And you can take b theta minus c and set it equal to pi, because that's our right asymptote. And then you can figure out where your asymptotes move for your transformed graph. Okay, as I said, notice that it looks like the graph has been reflected over the x-axis and shifted right by pi over 2. Okay, now we're going to discuss the graph of y equals cosecant of theta. Remember, cosecant theta equals 1 over sine of theta, or the reciprocal of sine theta. So let's go ahead and graph sine theta for us. Now, remember, vertical asymptotes are going to be where sine equals 0, and this is because 1 over 0 is going to be undefined. So our points on our graph that sine theta equals 0 is at 0, pi, and 2 pi. So those are going to be our 3 asymptotes. Okay. Now, moving on to other points. Our first set of points, those are at 1/2. So 1 over 1/2, or the reciprocal of 1/2, is 2. So those values are going to be at 2. Okay, next up is pi over 2, 1. So the reciprocal of 1 is 1. So this side of the graph looks like this. Okay, now over to the next part. These 2 points are at negative 1/2. The reciprocal of negative 1/2 is negative 2. The reciprocal of negative 1 is negative 1. So this part of the graph is going to look like this. And there, without the sine curve, this is your cosecant curve. Okay? You can memorize the important points of the asymptotes, so 0, pi, 2 pi. And then our next important point is going to be pi over 2, 1, and 3 pi over 2, negative 1. So you plot those points and then you make your curves up, or your curves down. Next is the graph of y equals secant theta. Remember that secant theta is equal to 1 over cosine theta, or in other words, the reciprocal of cosine theta. So go ahead and graph cosine theta. We're going to carry cosine theta out to 3 pi. The points that I have on the graph are 2 pi over 3, negative 1/2, 3 pi over 4, negative 0.7, pi, negative 1, negative, or I'm sorry, 5 pi over 4, negative 0.7, 4 pi over 3, negative a half, 5 pi over 3 1/2, 7 pi over 4 0.7, 7 pi over 3 1/2, and 9 pi over 4 0.7. Okay, we're going to be using those points here shortly. Okay, so our vertical asymptotes, just like with our cosecant graph, are going to occur when cosine theta equals 0, because 1 over 0 is undefined. So our zeros for cosine are at pi over 2, 3 pi over 2, and 5 pi over 2. So those are going to be asymptotes for the secant graph. Alright, so now the points at 2 pi over 3 and 4 pi over 3 are at negative a half. The reciprocal of negative 1/2 is negative 2. The points at 3 pi over 4 and 5 pi over 4 are at negative 0.7. The reciprocal of negative 0.7 is about negative 1.5. And then at pi, we are at negative 1. The reciprocal of negative 1 is negative 1. So this section of the graph, our secant curve, is going to look like this. Okay. Now for our next section of the graph, we are at 5 pi over 3 and 7 pi over 3. They are both at a half. The reciprocal of a half is 2. At 7 pi over 4 and 9 pi over 4, we are at 0.7. The reciprocal of 0.7 is about 1.5. At 2 pi, we are at 1. The reciprocal of 1 is 1. So in this section, the secant graph is going to look like this. Now, when we do graph secant, we get rid of the cosine curve and we only graph from pi over 2 to 5 pi over 2. Okay? We make sure we have our 3 asymptotes and then the important points at pi negative 1 and 2 pi 1, and then we draw the curves down and up respectively. Okay. Your homework is chapter 6.5, page 506, 7 through 12, 13 through 27 odd.